Hey guys, welcome back to my video. My name is Amaro Oshemi, and today we're going to be learning about the periodic table. So, as you can see, we have the periodic table in front of us right here. The periodic table is filled with elements, and elements are atoms. Periodic table are made out of elements, and elements are often known by another name called atoms. They are they are the building blocks of life. Atoms can't be broken down into small parts. The periodic table is broken up into columns and rows, but scientists um calls them groups and periods. Groups goes down like columns, and period goes across like rows. As you can see, this is a group, and this is a period. It goes across. The periodic table is mostly made up of elements that are metals, and there are over 75% of metal in the periodic table. As you can see right here, group 1, so it's right here, group 1, from 3 to 87, is called alkaline metals. They are the most reactive elements on the table, and um, the reactive, they are they mostly react around water, and some of them explode whenever they react way too much, because they're the most reactive elements and metals in the periodic table. Group 2 right here. Group 2. They're alkaline earth metals, second most reactive metals on the table. They are very unstable and also very reactive metals. So they're the second most reactive metals in the periodic table. Group 3 to 12, as you can see from this whole got group 3 to 12 is called transition metals. They are metals just like alkaline earth metals, but they hold their electrons differently than any other element in the table. As you can see in these black lines right here, I don't know if you guys can see it. Right here, these black lines, these are called the post-transition metals. As you can see, they are right next to the transition metals in groups 3 through 16 and period 3 to 7. They are mostly known as core metals, which means they are softer than transition metals. You can see these are lanthanide metals at the bottom, this green thing right here. They're called lanthanide metals, and they are all metals that are found naturally in the earth crust, but they're very rare. It's gonna be rare to get these metals. These are actinized metals. Actinides that actinides can be found at the very bottom of the periodic table, and but all they all fall into the metal category, but most are man-made. Most of the metals are man-made, so that means they are made in the science lab and can't be found naturally, like in the earth crust. They're man-made in a laboratory. Okay, as you can see these red lines. As you can see in these red lines, the element is in groups 13 through 7, and they are called metalloids. Metalloids are not metal but have similar properties as metals, but are sorry about that. They have similar properties to metals, and they have 7 of them in the periodic table. As you can see in these green lines right here, in group 17, there's a halogen. They are not metals but reactive and can bond most likely to alkaline metals. As you can work your way down, as you can work your way down the period, they become more stable. and especially this one, they're very like react. This is this element right here is really reactive compared to the bottom. Okay, the other non-metals is the purple lines right here. They're called other non-metals. They are not metals and they're not similar to metals. They're completely different from metals. They're not metals and they're not similar to metals. As you can see, oxygen, they're not oxygen is not a metal. Carbon is not a metal. None of this is a metal. And oh, sorry about that. So another thing I wanted to bring out is salt, right? As you can see, you have sodium, you have chloride. So this is the negative part of the periodic table, and this is the positive part of your periodic table. They'll most likely want to bond together, positive and negative. They'll most likely want to bond together, and which, as you can see, this is how we make salt: sodium and chlorine. If you mix that together, it's NaCl, which makes salt. Salt actually could do a lot of things. There's a lot of salt in like food. Wherever you go, there's always gonna be salt in what kind of food you eat. So salt could do a lot of things. It could boil water faster. It makes food have some kind of flavor, and it has there's so much to it. And as you can see, these translation metals, as you can see, they're stable and they hold their electrons more than every single element in the periodic table. As you can see, the silver, people wear silvers, people wear gold. They're very stable and it's actually you can actually use them. Back to what I was saying. I recently just talked about other non-metals. Now I'm going to be talking about noble gases. They're very stable and hardly ever react, and